So, our next speaker has been living in Scotland for 10 years, but can't do a Scottish accent. Despite living in a Harry Potter-themed apartment, and actually being a really good tour guide of Scotland. I hear stories where she brings data scientists all around Scotland to ghoul tours and castles, and perhaps more impressively, used to run the R user group in Edinburgh. So, everyone, please welcome Caterina.
Hi, everyone. It's great to be here. My name is Caterina Constantinescu. I am a principal consultant at Global Logic, and I will be talking to you today about deconstructing LLM use. And I'm hoping I can shift through the slides as well, which apparently I cannot right now. Let's try this. So in terms of GL, it is a consultancy with a global presence, and it is part of Hitachi. We also have multiple areas of focus, including generative AI, actually. So my aims for today include providing some structure in an area that actually has been progressing pretty much at the speed of light. So hopefully this will go some way towards helping you create more of an overview of what's been happening in this area. Hopefully there's also little bits and pieces here for a variety of levels of expertise. We shall soon find out. And I cannot really stress this enough, but the important thing here is this is only a starting point for doing your own research, which is also why you'll see a lot of references and extra materials dotted around these slides as we go along. So what you can expect in terms of the content is we'll kick off with a very short introduction, after which we will be talking about how to adapt LLMs for your needs. Here we'll be talking about starting points and how to kind of refine your models through a sort of model evolution. What I really want to dwell on more is the challenging areas. So for example, having to do with data collection, prompt engineering, and so on. And we will finish off with some conclusions, of course. But before I move on, I wanted to give a shout out to my three colleagues who have been working with LLMs for a while now, Afros, Brandon, and Nick. So in terms of the introduction, it will be probably no surprise that for a while now, we have seen this incredible accumulation of work in progress in this area of LLMs, which has been really compressed in a short amount of time. So of course, it's kind of a natural reaction to really want in on this amount of progress and figure out if there is a tool here that can actually help you along with your business problem. However, on the flip side, things can actually spiral a little bit towards this area of danger, somewhat. So we might be tempted to overlook areas that still require sustained effort, or maybe overstate what is actually possible. So hence this talk to kind of provide more nuance. A good starting point for our conversation will, of course, be the concept of base models. What these are essentially is more or less pattern completers. You can find them in a variety of places, Hugging Face especially, as well as some being on offer for via OpenAI. What is important to note here is even though you can get some use out of these pretty much out of the box, for anything a little bit more specialized, you probably quite quickly find yourself in the realm of needing to use in-context learning. What happens here is we still have the same parameters that are fixed within the same model. However, we give it a helping hand by giving it exactly that, more context, to factor into its responses. A couple of things are really important to note here. So this issue of temporal degradation. So because language is actually a pretty much living system, continually using a frozen model will have performance that degrades over time because it won't be able to kind of keep up with the dynamics of language over time. So that's something to note. There's also this concept of, actually, I should probably skip quite quickly because I'm noticing that I don't have a lot of time to spend on this, and I actually do want to get to the challenges. But key idea, in context learning will probably get you a long way towards what you want to achieve, but it does have some limitations, which is why a lot of people want to or are tempted by the idea of fine-tuning a model. Of course, there are trade-offs here as well in terms of cost. But if you want to have really good performance on a very specific task, you might lean towards this option, which does involve changing parameters. Therefore, you no longer have a frozen model. Things get a lot more dicey in terms of prompt engineering that hides a lot of complexity. And why I highlighted prompt tuning in particular is for some models and in some circumstances, the way you do prompt tuning might actually get you close to the performance of fine-tuning a model. So the idea is there's a lot of assessment to do here before you actually realize which of these makes most sense for you. Also, in this entire environment, we still have to think about things like orchestration tools, like LangChain, caching, and many other issues as well. The process doesn't even stop there either. We have additional processes that have to do with reward modeling and reinforcement learning from human feedback. If you haven't come across Andrej Karpathy's State of GPT talk where this is from, I do highly, highly recommend it because he goes into a lot more detail. Further advancement or enhancement of, let's say, natural capabilities from LLMs comes from plugins. The idea being that, let's say, if a model is fixed in time and basically only has knowledge of the world up to a certain cutoff date, you can enhance this by, for example, adding a browsing plugin, and so on. But we'll see that there are some trade-offs with plugins as well. So finally, the part that I actually wanted to spend the most amount of time on is this entire zone of challenging areas. And we will kick the conversation off with who are LLMs actually for. It's really tempting to answer this as why for everyone, of course. But that's missing on a lot of nuance. So for example, what if your users also include older generations that maybe don't even want to interact with a large language model? Maybe they actually want to see people in store and have a conversation with them. What about visually impaired customers that maybe don't really have a good fit for LLMs? OpenAI, as it turns out, is currently working on this, but it doesn't seem to be the focus, broadly speaking, in this whole area of research. And then, again, we come back to this idea of trial and error prompting and figuring out what is the best way to extract knowledge from a large language model. So in some cases, for example, large companies are pondering the question of, should we actually get our people on prompt engineering training to actually make sure that they can use these models better? So big questions and interesting approaches. On the side of inputs as well, in terms of fine-tuning, it's really important to note that there might be discrepancies there as well. So fine-tuning is better suited for high-quality data, which might deviate from the type of language that people normally use. So that could actually lead to some problems as well. And last but not least, in terms of who are LLMs for, I found this really interesting survey from The Verge. Very few details in terms of how they've done their sampling, but it's important to note that in this sample at least, 43% of people hadn't even heard of ChatGPT, so that kind of gives you a little bit more context of how these things might fare out in the real world. In terms of data collection, pre-training itself has a lot of gotchas, because what might determine how a model performs or behaves in real test scenarios has a lot to do with the type of data that went into it. And as you can see, there is a huge amount of variation across various models. Not only that, but models as shown in a particular body of research might actually get stale over time, as mentioned before as well. Fine-tuning in terms of data collection, again, as mentioned before, has particular requirements in terms of data quality as well as amount of data that you might be able to use. OpenAI, as a rule of thumb, require at least a few hundred examples, but in Andrej Karpathy's slide from earlier, it may go all the way up to 100,000 examples. It might not be a trivial task to gather that many. However, a few tools might come to the rescue, such as Wizard LM mentioned there, that might give you a helping hand to kind of prepare things in a way that can be used for fine-tuning. Also, it is not necessarily a one-time deal. You can repeatedly refine the same model. Prompt engineering, probably one of the most notorious topics in this entire area, which is also, I hope, fair to say, more of a dark art than a science. A lot of experimentation is involved here in terms of figuring out what is the best way to elicit an answer that is useful to you from a large language model. It also comes in a variety of forms, which importantly are not mutually exclusive, as we will see in a second. So, for example, you have zero-shot prompting with some examples there. What we're essentially implicitly requesting from a model is that it complete the pattern and kind of fill in blank spaces. If it's not very clear what exactly we're requesting for a model, few-shot basically builds on that and provides more of a pattern to help in this kind of completion process. And finally, we have something like instruction prompting, where we make very explicit what exactly we're asking the model to do for us. These are not without their own problems. So for example, instruction prompting and zero-shot actually assume a little bit more model refinement, whereas few-shot deals with the idea that there's a finite amount of context or examples that we can provide to a given model, because the more detail we provide, probably the higher the costs and the higher the latency as well, which nobody really wants. That aside, there are a variety of other techniques that I'm not going to be able to go into today, unfortunately, but I do have a resource there in case anybody is interested. I will say, for example, chain of thought prompting is particularly popular, but is by no means the only option. What I was after by adding this thread from Twitter is to point out a few really insightful nuggets from this prompting battle that some people did for fun. The idea there is that somebody or LLM users or researchers do not necessarily have transferable skills. In fact, if somebody's really good at prompting a certain model, that doesn't necessarily carry over to others, which is what is explicit in these tweets. Also, something that might happen is occasionally, even if as a human you might think a certain task is trivial to achieve, even something like GPT-4 might not be able to complete that task. So that's something to be aware of. And I didn't want to leave this conversation on prompt engineering without adding a particular bombshell from Ben Evans, whose blog is definitely worth checking out. But there he basically says there's a discrepancy between the idea of natural language and how much finessing needs to go into these prompt engineering attempts. So that's an interesting idea to leave you with. Real-world performance. This is something that I think is really important to note. So basically, this entire area of how do you evaluate a large language model typically hinges on a lot of academic research where you might have benchmarks that contain even hundreds of tasks and metrics. So things like Big Bench would be a good example for that. However, that does not always necessarily tell you much about how these models will behave in the real world to actually solve somebody's problem. Something else that has stirred particular debate on Twitter as well is this approach to evaluate one model by using another model as its judge. It's called LLM as a judge, the approach. So because of this discrepancy between real-world implementation and behavior of these models and how things appear via academic tests, we might run across situations like ChemCrow, which seems to be performing roughly equivalently to GPT-4, even though it's supposed to be much more targeted towards use cases like drug discovery, and it's only when actual domain experts were able to test them that they could actually see a huge difference in between the two. So that's really important to bear in mind as well. Now, all of this had to do with real-world performance from a usefulness perspective. But it's really important to also be aware that we're talking about a different lens as well in terms of what is the impact on the world of these models. Suleiman and colleagues come up with these 7 criteria that help us to really evaluate models from a different standpoint. Again, unfortunately, not a lot of time to go into all of these in detail. However, the one that I would point out right now is the last one on the list, so data and content moderation, labor costs. So this entire theme of crowd work is under scrutiny just now, and a really good resource to go to is Josh Jez's article for The Verge, where he basically goes undercover, signs up as a tasker for doing a lot of labeling work for AI companies, and kind of describes what that process even looks like and what people have to go through to do all this mountain of work. In terms of licensing issues, this is also an important thing to bear in mind if you think LLMs might actually provide something useful for your particular problem. The idea here is that licensing issues affect not only the models themselves, but also training data. But more than that, models need to be seen in the context of their lineage, if you will. So one model might be basically an updated version of a different model that already came with certain licensing constraints. So it's important to actually be aware of that before actually building use cases on top of anything. Security is a really important issue as well, and actually has some touch points with conversations and talks from yesterday, as we'll see. I think a really important thing to note straight off the bat is there is no built-in concept of access restrictions with LLMs. It's more of an issue of, is your prompting clever enough or suitable enough to actually extract the information you want from a large language models, but there aren't restricted areas, so to speak. And this is also an area that is receiving a lot of interest and additional work. In terms of package hallucinations, Jared's talk yesterday actually provided a really good example of this. So he actually generated some code via ChatGPT, and one of the imports there was a package called eChartsR, which actually doesn't exist, but is very plausible, and it could have existed. So what this opens up in terms of possibilities is situations where plausible packages like that don't exist, a malicious actor could actually create, add some malicious code in them, and then somebody unsuspecting might run code generated by ChatGPT and actually pull that down. So that's important to be aware of as well. Another potential area of vulnerability has to do with plugins that we mentioned earlier. So Embrace the Red blog actually demos how this might go and gives us an example of a plugin that pretty much turns your repos from private to public. And OpenAI themselves actually caution us against using plugins without really looking into them too much. Prompt injections are another particular problem. There are tools that target that, but it's also important to do some digging and pretty much beef up any kind of security vulnerabilities that these models might have. Right, so in terms of our conclusions from this entire conversation, I think one thing that leaps out immediately, and I think I will kind of provide a bit more evidence as we keep going with the conclusions, is that generative AI is a raw material. You shouldn't perceive it as a finished product that is ready to use and just embed into processes directly. And this is because on a technical level, and there will be other angles to look at as well, there are all these non-trivial questions that need to be addressed and do take time to address. Things like, should you fine-tune or not fine-tune? Maybe you don't have to if something like prompt tuning will get you most of the way there anyway. But all these things need to be tested to be able to tell what you should do. How do you even assess model performance? As we've seen, this is an entire discussion as well, because you do, on the one hand, have these academic metrics or tasks, but do they actually reflect a real use case? Maybe not so much. How specific is the problem that you want to solve, and will perhaps a small model really help you out, or do you actually have to use something which is a lot larger in size and has a lot more parameters? Maybe it's not really that useful to you, depending on what you want to do. Another angle is the usability angle. Something that I don't think is discussed a lot is this experience design issue. We only talk about mostly the technical aspects and implementation details from a technical standpoint, but in terms of people actually interacting with these systems and what we want them to actually, what type of experience we want them to have, that's not so much a concern as far as I've seen typically. And this is maybe the most important thing on this entire slide. A really important thing has to do with a paradigm shift in our thinking of what these models can actually offer us. Typically, what we're looking for is deterministic thinking and answering a question very factually, but what these models natively actually tend to do is tell us what is the plausible answer to a particular question, and sometimes the difference might be huge between the two. More along the same lines, they offer a second pair of eyes, and they can act as co-pilots, but don't actually trust them to do your job for you, which is why I wanted to pretty much finish off with another meme. And also a provocative idea that maybe the likes of ChatGPT will not take away people's jobs. In fact, maybe they will free them up from a lot of tasks that would take them longer, and in that case, the type of growth and progress that comes from that will actually attract more jobs. Which is the point Ben Evans makes as well. And as per usual, and as mentioned before, this is such an active area of research that it is of paramount importance to do your own research, but you can have this as a starting point, and these slides will make their way on my blog, which is what that QR code leads you to. Thank you very much for listening.